Okay, so we are recording. I'm going to break tonight into two different videos so that you don't have to sit through a whole bunch of chapter 6 if you're just tuning in for the test review. So I'm relying on those who are in here. If I start doing the test without changing the video over, make sure you check with me, make sure I did. Okay, so, and also, cool. I need to share screen. Gonna share screen number 2 here. I was told that I needed to start using the PowerPoint presentations in the method for which they were designed to be used. So I get to show it as a PowerPoint presentation. Cool, huh? So there's only 63 slides in chapter 6. We'll buzz right through them. Should be done in a couple hours. Can you see the MATLAB for Engineer 6th edition?
Yeah, you're good.
Okay, you don't see the one with all the next slide, because I think I got the right one shared. Okay, all right, so we'll go ahead and get started here. This is chapter 6 from the 6th edition of MATLAB for Engineers, written by Dr. Holly Moore, who is, I hope she's having a great time. She's actually down in Texas right now. She gets vacations. I don't. I get to work summers. There's something wrong with that. Anyway, I digress. Anyway, so this chapter 6 is on user-defined functions. So these are the learning objectives of this chapter. By the end of this chapter, you should be able to create your own MATLAB functions with multiple and single outputs and inputs. It sounds complicated, but it's really not that hard. Okay, I keep saying that because it's easy for me because I've been doing it for 100 years, but serious, it's not that difficult to change from a single input to multiple inputs, and we'll cover that in a minute. You should be able to store and access your own functions in toolboxes, create anonymous functions, and that's one that students in the past have had troubles with actually understanding what an anonymous function is. And we'll get to that. And then create and use function handles, and there's a little bit on that one. And then create and use sub functions and nested sub functions. For this class, I mean, it's probably okay to learn how to do that, but we'll teach you how to do it. Okay, so come on, advance, I said, advance, you kumquat. Okay, so introduction to this chapter. Basically, this just goes and says that functions are a huge part of computer programming. Most of what you've been doing right now has been using built-in functions, your max, min, all your trig functions, mesh grid, plots. Those are all built-in functions. They require an input, and most of them give an output. Technically, an output from a function is values that are assigned to a variable that can be used for further calculations, whereas your plot functions don't necessarily give an output, they create a plot. You can assign a handle to that to get other things necessary. So it's not necessary for you to know how some of these built-in functions work. Just have comfort in the knowledge that they do work. They shouldn't have any errors, bugs in the built-in functions of MATLAB. Okay, so we'll start off with the basic creating of functions. Functions have they could be stored in either individualized M files or a separate live script editor. Up until a few years ago, that was the only, even before the live script editor, the only way you could create your own user-defined functions was in its own M file. And then somebody along the line got smart and says, oh, hey, well, let's make it so we can put these all in a single file. And back in the early days of this chapter 6 was a nightmare to grade because there were like 24 functions that had to be turned in with the main script file. and they all had to be individually submitted, and then I had to individually download each and every one of them. And now with the advent of the live script editor and even in the M file now, you can build these functions in the bottom of the file. It's convenient. You only have one file to turn in. The major difference between the two is the separate M files or live editor files. That function is accessible to any program you write in the future, as long as it is in your current folder, or if there's a path created to go to the file where those folders are, or a path going to the folder where those files are stored. If you write them at the bottom of the M file or the live editor, they are only accessible in that single document. So for this class, I would ask, at least on this assignment, that you write them at the end of the file. It makes grading so much easier, and we got to remember the very first golden rule about the grader, and it's you always want to keep that grader happy. Okay, so yeah, so they could be accessed if they're in the MATLAB in a current folder, located on the search path, and there's a few slides in here that shows you how to set that up, or at the end of the live script function. Inside it can only be, look at that, see, I get ahead of the PowerPoint. Okay, so a local function is only visible to other functions of the code in the same file. So that's the stuff at the bottom of the M file or live editor. Okay, so the syntax for building a function. It consists of a name, a user provided input, and an output. Generally, most of 99% of your functions will have an input and an output. Not all functions require that, and we'll cover a few of those here in a little bit. Can I move this thing here? Let's get that down so it's out of that. Some of the built-in functions that you've been using already, like cosine, it requires a single input, which is an angle in either radians or degrees, depending on, well, for cosine it would be in radians, and it returns the cosine of that angle. Calculations are done in the background. You don't even know what's going on. You just assume that it's someone's creating some voodoo, and everything works out hunky and dory and works, and it gives you the nice plot and calculations and everything you're looking for. The functions you write will work in the exact same way. You'll provide it with a name, an input, an output, and then your source code inside to do the manipulation to the variables that are sent to it. So, what's next? I don't know. Here we go. So function structure. When you're creating functions in MATLAB, they must, and this is a given, they must follow this structure. The very first line in your file, whether it be at the bottom of the file, if it's at the bottom file, it needs to be in its own section, meaning that it needs to start with, the section needs to start with 2% signs and a space. That will create a new section. Then underneath that, you put in all your functions. The very first line of that function needs to be the word function. And then after that, you put in the return variables right here. So this is function. That's the first line of that code. This is the return variable. It can be any variable name you want, any valid variable name. Personally, I like to use either results or output, because that tells me that this is what's being output to the main program after the function has executed. But you can call it whatever you want. This here would be the name of the function. When you actually write a function in MATLAB and save it to its own individual file, when you hit save, it'll automatically put that in as the name of the file, and that's what it needs to be called in order to properly work. And then this is your input variables. Again, all of these are user defined, but can't stress enough the necessity to use variable names that make sense. Too many pop-up windows here. Just to help keep your head straight so you know what you're doing. It's hard to be dealing with 15 different variables and they're all named something arbitrary. You don't know which variable is doing what and where it's supposed to go, and it's very, very complicated. So anyway, so we get into here. So here's the function name. There's your input variables. There's your output variables. And then here is this is a little hint that's saying that input, here we say input variable. Just got to keep in mind that in chapter 7, when we get to it, input is an actual function that allows the user to input data into MATLAB. And that's completely different from what we're talking about here. The input variable is just a description of that variable. It's not a function. Well, it is a function, but it's not the function that we want for user-defined functions. Okay, so functions stored as separate files. So here you can see that this is a function with an output variable, and the name of the function is poly with one input. And over here in the current folder, you see a file, and this has a little icon showing that it is a function. And it can be stored as either an M file or a live editor. Either one will function, or I guess I shouldn't say function. Either one of them will work and actually execute when called upon. And this one is returning a single output. The function name must be the same as the file name. The last line, oh, that's another thing I forget too. Yeah, okay, you didn't hear me say this, but if you're doing a separate individual file, at least in the olden days, you didn't need an end at the end. You just had to do your code, and that was it. But with the coming of putting files at the end of the program, it is now required to have an end at each of individual function. That way it knows where this function ends and the next one begins. And I believe that's also common programming structure for C++ and all of your higher coding software forms. See, it's not strictly, but it's good programming practice. See, told you. So, and then once it's been saved, other programs can be called from within that main script file. Well, not the function file. You can only do a function in a function file. You can't execute the function file. Like, you can't go up here and hit run section in a function. It won't do it. It'll scream at you and say that's not allowed. But once you've saved it, then you can go to the command window or another file and call it up just like you would any other function. You know, here you'd say poly 3, and it would put 3 in everywhere there's an X and calculate it and return, poly 5, and then return 491. A function stored as part of a larger program. This is where you're putting all your functions at the end of the file. You can put as many functions down there as you want, as long as they're all in it only needs to be in, I think it can only be in one section. I've never tried multiple sections, just one section, and I usually call that one functions, and then underneath that line you start writing your functions in. They must be stored at the bottom, and each must be terminated with an end statement. And that works in both M file and the live editor. And then here's a hint for you. This just basically says that, you know, while you're creating your function and editing it and getting it to run fine, it might be beneficial to allow the outputs of each line to the command window so you can see what's going on, make sure things are calculating properly, and then once you've got it running perfectly, then go back in and suppress the output. Otherwise, you could end up with double input into the command window, because you'll have the output from the statement and the function and then back into your main program. It's just programming etiquette, I guess. Solving problems from the script. When you're when you're running them in an M file, and the functions down at the bottom, you run the code up at the top of the, you don't run the function, you come up here. So this one is square, so you would run this cell here. I'm sorry, if I call a section a cell, that's because for the last 20 years it's been called a cell, and then all of a sudden in the 6th edition we're now calling it a section. So this section, when you run this section, it sees this square, it looks and it's down here, and if it finds it there, then it executes that. If it can't find it there, then it searches its memory. If it can't find there, it goes to toolboxes. If it can't find there, it goes to a programmed path. If it can't find there, and then it kicks out and says, unknown function. But you just write, oops, go back, right. Come on, get on there. There we go. If you're in the cell and hit run, well, actually, if you hit run, it's going to save the file and start at the top and run its way down, which I guess you would need the X in here because that's down there. But if you try to run just this section down here, it won't work. And a live editor, or in the M file, your output is put into the command window, whereas in the live editor, it's displayed in the live editor. A lot of you have been doing the live editor, and that's cool. I like that. It is harder to grade, mostly probably because I'm not used to it, except for on the exams, but I'll get there. Don't worry. I'm hoping it's easier for you guys. Okay, so place of functions at the end of the program. Again, this has created a section down here for the functions. But this cannot be accessed from outside of this this file. So if you went to another program, created a new live editor and tried to get this function, it would not see it. And then make sure you terminate with an end. Comments, lots of comments. In any comments that you put after the function line, you can put as many comments as you want between that and your first arguments. That's what will show up in the command window if somebody was to type help grain _ size. It would display any comments that are underneath there, which is good for telling what the function does, what the inputs are, and anything that the user might need to know how to run your function. If you guys have questions, by all means, pop up and say, "Hey, stupid, what about this?" You can't hurt my feelings. I have none. Okay, so among functions with multiple inputs and outputs, a multiple output argument is just exactly the same as a single, only you get 2 variables in here, or 3, or 4, or as many as you need. And they just go inside of the parentheses separated by a comma. And then you can use them both down here just like you would in any other kind of calculation with multiple variables. Again, if you want to make it so that it's available to use on arrays, you make sure you use the element operators, or the dot times, dot raise, dot divide, whatever's necessary for that to happen. Also, I can't hardly stress enough that if you're going to send 2 variables in here like this, I try to teach my students that it's best that you put mesh grid inside of your function. That way you're not requiring the user to remember to mesh grid before sending them to the function. To me, that just makes a lot of programming sense and makes it easier on a grader who has to enter the data every time. Oh, that grader is so picky. So there's 2 inputs. When the X or Y define a command window, G is vector output is return. It's just working as a function like a function should. So you can see that the G, this was in its own file, so it's saved as a separate. Otherwise, it wouldn't work in the command window. Although the intermediate values, that's another thing that I'm sure we'll get to here in a minute, is that variables that are created inside of the function are local to the function only. They do not show up in the current in your workspace. They're not over there. The MATLAB just uses them, and then when it gets to the end, it throws them away after passing back the stuff. So just keep that in mind. And also, it cannot access things that are over here. Only thing that you can have access to in the function is what you pass to it. Nothing more, nothing less. Oh no, my internet connection is unstable. I hope you guys are reading this. Okay. Functions with multiple outputs. If you have multiple outputs, we've encountered this already in the max and the mins. If you assign the output of the max and min to two variables, the first one receives the maximum value, and the second variable receives is assigned the location. Oh, look, see right here. In order to do this, come on, you just put your output variables, as many as you want, inside of square brackets, and then make sure you assign something to all of them. And now, if in here, like on the max command, if you assign it to only one value, it gets the first variable. So to get all three of these, you need to assign it to three different variables. There we go. That's the word I was looking for. Sorry, it's been a long day. Okay. So this is again just, I don't know what she's. Anyway, it's in its own M file, therefore it's accessible anywhere. That's why this works, and it's not at the end of the program. It could also be saved as an M file. It's up to the programmer. So yeah, this one is saved as a live editor because the MLX is a live editor. So anyway. See, here we go. See, if you call it up without specifying all three outputs, it'll only return the first one. Man, I gotta quit getting ahead in my PowerPoints. That's why I don't like PowerPoints, is because I can't remember everything that's in the PowerPoint, and then I ramble on and end up covering stuff that's coming up. Okay, functions with no inputs and no outputs. Yeah, you can do that. In order to do that, no inputs, you just give it two, open close parentheses with nothing inside, and no outputs, two square brackets. So here's an example of a star function, which is going to do a polar plot of a star. So you can see here that the only output is that plot. But again, there are no values returned, but I figure we'll put showing a bar of polar plots. And okay, then if you want to take the grid off just so you have the star itself, you can use the axis off. What that has to do with this is beyond me, but sorry, Holly, I didn't mean to say that. I don't know if she's watching these or not, so I guess. Anyway. So here's one error that I noticed in the textbook, and I've talked to Holly about it, is this line right here, and it says, it's an example, it does not, after all, it draws a star, but the output of function is defined as a value that is returned when you call a function. A star is because it does not return anything, thus it is not set equal to, and this is what I have issue with, is because in earlier chapters we stressed that the equal sign, when you're doing this, does not set it equal to, but assigns a value to that variable. So this should be changed. I think I've already told her about that one, but she may have forgotten. Anyway, okay, so star doesn't return a value, it just returns a plot. Because, see here, yeah. This was just showing that if you try to see A equals star, it just, there's nothing there. Too many output arguments. Okay, so some of the other functions that you've been dealing with that have no inputs or output, well, inputs would be pi, and I don't know if we've used clock yet. Tick and tock would also be without inputs. We get into TikTok here pretty soon, and it just calculates how long it takes to execute some code. Just because it doesn't return the value doesn't mean it's useful or doesn't do anything. Obviously, pi is a very valuable function. So section 6.1.5, determine the number of inputs and outputs arguments in a function. I guess there are sometimes you'd want to know how many inputs are required and how many outputs are available. You can get that by using the n argument in and the number argument out functions, and they both name of the function to be analyzed either as a string or as a function handle, and we'll discuss in function handles here in a little bit. So number arguments in is used when the function definition returns an actual entered, and why you'd want to do this in your homework is beyond me, but it has become very useful for the MATLAB grader to make sure that things are being programmed correctly. So here's some examples. The number of arguments in for sine is 1. Number for rem, which gives you have to put the number that you're dividing in the divisor, and it'll tell you what's left over. So you got to have 2 inputs for that. Surf has a -1 because it can be either a single value or 3 inputs. You can do, if you just do one value, it uses the x, I believe the x and y axes are just element numbers, and the z is the values, or you can specify x, y, and z. And so that's why that one's a negative number. When it's used inside of user, how many? Okay, so she does have an example here where you would use the number of arguments in, which is kind of neat, I guess. And I think this one's in twice. Well, size is a function that reaches the defaults. We'll get back to that neat thing that she did with the number of arguments in. So variable arguments out example. Here's a function that she got from the documentation on my size. So if you want to get read some background on this stuff, just do the doc my size, and it'll pull this up, and you can look for it and see here. So it's looking for the size of the vector that was brought to it and the v argument out. And then this gets into a for loop, which we haven't studied yet, and font size -2 indicates that it's a variable already. So it doesn't require. So there we go. You can get this by doing doc number argument in. So here's where she used it as an example. So again, we're going back to the star. So she called this, and she has one output argument A. And down here she says, if number of arguments is not equal to 1, then the name of the thing is going to be Twinkle Twinkle Little Star. And so there we go, because there was no input. So say that's cool. Yeah, man, that is so cool. So it's again, we haven't discussed if statements. Those come in chapter 8 or 9, one of the two. 8, 9, 8. I don't know, we'll find out here shortly. Local variables, again, as I said earlier here, that all the variables inside of a function are known as locals. They're only accessible to the function itself, and also the variables are not available outside of the function, and variables outside of the function are not available inside. The only thing that the function can deal with is what is passed to it and what it passes back to the user. So here you can see that in this one, the variables A This don't make sense to me, but so A, X, Y, and output are all local variables. Personally, that's 1, 2, 3, 4 extra keystrokes, and you could just say the output equals that. But that's all programming style for everybody's individual style. Let's see. The function G is also using the same variables, but they're not stored in the workspace. So you can see over here in the workspace, this has been executed, but there is no A, X, Y, or output, just the answer from executing the code. I just said that. Okay. So if we try the variable A from the command window, an arrow is generated, because once the function is done with the variables, it forgets all about them. So functions cannot be accessed, cannot access the main workspace. Functions, I've covered this, can only go what's given to it. So here there's an example of this distance has a gravitational constant in there, but it's not passed to it, but it's here in the workspace, but it can't find it because it's not been passed to the function. So in order to fix that, you need to put G in there or pass it to the function. So here, same arrays names. Yeah, you can use the same names inside your functions as in your main script file. It won't overwrite the ones in your main script file. Again, all functions inside of all the variables inside the function are local to it, and they're forgotten after it's done. Global variables. You can do global variables. So this is the only accession of being able to access external variables from a function, is to declare them as global. But it's generally not advisable to do this. So here we just define global G as 9.8, and it'll run now because but you still have to define it inside of your program. But still, it's just not good programming style unless it's absolutely 100% necessary to define it as a global variable. As a kind of when you guys can think of the word I'm trying to come up, but it's generally just programming standard to do global variables. It's uppercase. MATLAB doesn't care, but it's easier to identify if everything is all uppercase. You know it's a global variable. But again, try to stay away from them if you absolutely can. So this is in the textbook. If you want to read it, it talks about how you don't want to use globals because it'd be like putting your credit card out as a global thing for any store to go in, and then you have no control over what happens to it. Quit using the mouse button. There we go. Accessing function code. So functions provided are two types: the built-in and other type are stored in toolboxes. We can see these function files with the type command. So if you type in a type and then the function name, it'll give you a whole bunch of information. Quit doing that. I keep trying to get this screen over here to scroll up, but it won't do it because it's in a picture. It's not actually MATLAB. So this will give you some of the breakdown on the contents of that function. Yeah, cool. Far out. And then again, this is a variable argument and to indicate that it will accept variables of number of input arguments. So it's not a specific number of inputs. It could be either 1, 3, or however many. Yeah, cool. So subfunctions. I had one student one semester who did all of his homework in subfunctions, and it was kind of annoying. But if that's how you want to run your homework, that's fine. I won't criticize you. But basically, a subfunction is just a function. Your main program is a function, and then all of your other functions are inside of it. There'd be an example here how to set that up. One disadvantage is they're only available from the primary file and cannot be used by other programs. So that's why these are called local functions. And it's advisable not to attempt coding this way until you've mastered simple functions first. So this is sequential subfunctions. So this is how I'd like to see you do your homework, with each problem in a section above with all your functions below. Then I can just start at the top, work my way down. I can get down, go down to the bottom, check out your functions, make sure they're right. This is a good method for homework. Now you get out in the industry, they may not want you doing your stuff like this, which makes sense. Although when I told our data analyst who does all our software programming for analyzing our data, she really liked this ability down here. So yeah, cool. So using subfunctions and other functions, the primary function store must be subfunctions. So here is how this one student did it. So the first line is making this whole file a function, but it's a subfunction. And then it listed the names of all of the functions below, or not necessarily, it didn't list them, but it does this here. And the problem with this is I couldn't run individual cells, sections one at a time. You have to run the whole file. So it poses a challenge to the grader, but hey, the grader likes challenges sometimes. But so this is how it's done, just a function on top, and then again, it's a similar function or setup with all your functions at the bottom and the code at the top. And so there are your two subfunctions. Creating your own toolbox. When you call a function in a MATLAB program, looks for the function first at the end of the program file, then in the current folder. Hey, that's what I said earlier too. Yeah, okay, and if you can't find it there, then it starts at other locations and a predefined search that looks for the function name, set a path. This is how you can set your own path. The only reason I don't advocate doing this is because if you set a path to where your files functions are saved, and then I try to run your program, it won't work. Because I won't have the same path on my computer as you have at home. Well, yeah, maybe. Oh wait, no, that's only when saving. If you do, okay, so if you set it up in your individual MATLAB, that's fine. You can do whatever you want. I mean, if you want to set up a separate folder on your computer to save all your functions in, that's fine. Then go in and do the set path, or either the set path, or I use the path tool in the command window, and it brings up this window here, and then you can add a folder, and it just like any Windows browser, you can browse to a folder location, input that, and then start saving your functions there. Then it doesn't matter what your current folder is. If it can't find a current folder, it'll go to that location and find the functions and run them. As long as you set it up this way in your MATLAB, that's great, but don't set a path inside of your MATLAB code to go to a different folder, because then that's when I have problems. Because if you put Like this, if this one here was in your code, this file doesn't exist on my computer. So I've had problems with that before. So add folder. Yeah, come on, Holly. You should add, and you should ever make changes to public computers. Okay, anonymous functions and function handles. So if you're going to use some kind of a calculation over and over and over, but you don't want to do a user-defined function, you can do an anonymous function. So this one just reassigns the name of the log function. Well, it doesn't reassign, it creates a new function, an anonymous function inside, and this is inside the script file, not down at the bottom, not in a separate folder. This is up in the main script file where you're doing all the rest of your work. So this is going to reassign log, not reassign, it's going to create a function called ln that is going to assign it a input of x to the function log, and then this is where it will substitute x in every time it sees it. So the @ symbol tells it that it's a function. Immediately following the symbol is the inputs of the functions labeled in parentheses. You can have more than one. You can have as many as you want. In fact, there's an example in here as to why another example is to a benefit of doing these anonymous functions. And then the function is defined. It'll appear in the, oh man, my connection's unstable. Hope you guys are hearing some of this. If not, it'll be recorded and posted later on tonight. It'll appear in the workspace as a function handle, and then and it can be just used as any other function. You just type the function name followed by the inputs in parentheses. So here it shows the ln, and it actually shows the function because it's short enough to fit in there, and that it's a function handle. So they're stored. They can be used like they disappear once the workspace is cleared, and an anonymous function. Okay. So they can be saved as mat files, just like any variable, and can be restored with the load command. I've never done this, so it'd be interesting to see if it brings that back up. So, well, yeah, it should just bring that back up as that code. I do know that, if you save the variable, it'll save this value, but it doesn't show you how it was created. But this would have to bring this back up. So it's just save with the name of the function that you're saving it as and which one you're saving. So that's cool. So it's restoring it, and then just type in load and then the function, and it'll load it back in. Well, let's say it did. Okay, it's possible to assign a function handle to any function. A function handle is so this is the function handle distance handle, and it's basically using the same syntax as the anonymous function. The @ symbol followed by the variables in parentheses, and then the function for which you're sending the handle to, or the handle is being assigned from, and then the inputs. Why would you want to do that? So here we go. Here's perhaps you're using this complicated function that has 5 inputs, and you're going to be checking various different iterations of the function, but only one value changes, and you don't want to have to enter this in every time. So if you set up an anonymous function you define all of these prior to the function, and then x is going to be your only input, then you would just have to do a new func, and with the single variable changing would be x. Functions. I've never heard of functions until I read chapter 6 in the 6th edition, so this is new stuff for me. They have an odd but descriptive name there. Functions required, other functions as inputs. Okay, so I've never heard of fplot being called as a function. But fplot is a function. It's a plotting function that requires a function as an input. It requires the function and the range over which to plot it. And that was brought up over the last chapter, which, I don't know, that was kind of, do you put the horse before the cart? Or, you know, but it fits in the plotting because it was plotting, but it's a function. Does it go in a function? Okay, so anyway, I hope we got through the F-plots okay without any issues. But as you remember, the F-plot just takes a function input and the range, and then, you know, it's your standard titles and labels and everything else that's neat, knife D and all that other good stuff. Okay, so that's user-defined functions. The summary, MATLAB uses a lot of built-in functions and user-defined functions. To create a user-defined function, you need to specify function, the output variables, the names, the input variables. Must also be the name of the file for which the function is stored, and it's got to follow the same naming rules. You can't have a function begin with a letter, not a letter, with a number, or there can't be any special characters. It must start with a letter and contain only letters, numbers, and underscores. Built-in functions can accept multiple inputs, multiple outputs. You can put code in there. Would you be quiet? To get help. Store to local functions, global variables. Good programs say don't use. The global variables are capital letters, but not wise to use them. Okay, and this copyright says you guys won't use anything that I just showed you because they don't want you to. Okay, so any questions? If anybody's still with me on chapter 6.
I'm Harvey.
Burke, you, Aiden, got any questions?
No, I'm good.
I'm also good.
Okay. Was there any breaks in that? I kept getting a notice on my screen saying that there was internet connection issues.
You would cut out a little bit, but it wasn't like we couldn't hear you for any decent amount of time.
Well, I'm sorry. We just put in a new modem, and maybe that's what I need to do when I'm doing this kind of stuff. Is if I have, maybe I can't. Maybe I can't. Oh, no, I can't. Sorry, because I have an Ethernet cable sent over to my desk because my office does not want me using Wi-Fi at home on their computers. But we just updated our modem, and we have gigabyte speed if we're connected via an Ethernet cable, but Wi-Fi really